Proceed to our sample problem number 3. The 10 kilogram block is subjected to the forces shown. In each case, so natin dua ka case, si case A ug si case B. So di ni siya case the red horse but two cases or situation. Determine its velocity at S is equal to 8 meters. So S here denotes the distance or the position. If the position is at 8 meters, the velocity, if velocity is 3 meters per second at the position S is equal to 0, motions occurs to the right. So ang motion is occurs to the right. Na natay gihatag nga motion. So here, the initial velocity is not equal to 0 because it does not start from rest, but we have an initial velocity equal to 3 meters per second. Okay, let's write what are the given. So for our sample problem number 3, we have a mass equal to 10 kilograms. So ang weight sa object is just equal to mass times the gravitational acceleration, 10 times 9.81, that is equal to 98.1 newtons. So pay gihatag sa 2a. So ni velocity at the distance is equal to 0 meters is already 3 meters per seconds. And then we were asked what is the velocity at the position 8 meters. So we have two cases here, case A and case B. So ito sa drawing. This is case A for the case B. So sa case A, naay force sa ibabaw nga 200 newton. Naay force along the left side equals to 30 newtons. Force along the right is 40 newton. And then for the case B, isa lang atong force dire is equal to 2.5 s newton. Sa ato pa, this is a function of the distance nga s. So say sunod nato buhaton ani sir. Okay, let's consider each cases. Okay? So let's start with case A. So again, as the motion moves occurs to the right. So kung imong tan-awon diri, this is a horizontal plane, na 30 paingon dito, na 40 paingon dito. Natay summation of forces, ang mabilin is 10 newton to the right. It means that this object moves to the right na gyud. Making the FBD. So ang force along right is 40 newton. Force along left is 30 newton. Natay downward force nga 200 newton. Don't forget na naatay normal force plus napatay weight niya nga 98.1 newton. So we have it here 98.1 newton. Since ang ato ang acceleration is only to the right along the x-axis, wala tayong acceleration sa y, then we can simply assume that the summation along the forces y is equal to 0. It pasabot wala translation. So from this equation, we can solve for the normal force. So the normal force is just equal to 200 plus 98.1 newton, which is equal to 298.1 newton. So importante ba siya here to get the acceleration? So again, we were not given the mu k. So therefore, the normal force does not matter in this problem. Since the acceleration of the motion is towards the right, then we need to get the values along x na lang. So that is summation of forces along x is just equal to the mass times the acceleration. So natay along forces along x, we have 40 newton minus 30 newton is just equal to the mass of the object 10 kilograms times the acceleration. From this one, we can get, further summarize it here, we have 10 is equal to 10a. So therefore, our acceleration to the right is 1 meters per second squared. Now, what unsay mahitabo? So, With the constant acceleration ng kinematic equation, we have the square of the final velocity is equal to this square of the initial velocity plus twice the acceleration times the displacement, delta S. So, sa may tabo, we don't have the final velocity or velocity at 8 meters. So, let's remain that unknown. Atong initial velocity is 3 meters per second. So, square that one plus twice the acceleration 1 meters per second squared. And then the displacement is the final position, 8 minus the initial position, that is 0. We can have v squared is equal to 9 plus 16 equals to 25. You extract this to square root. Therefore, our velocity at s equals to 8 is equal to 5 meters per second to the right. At s is equal to 8 meters. So this is the answer for the sample problem number 3. Again, since ang motion is along right, yung direction sa acceleration, dili zero atong summation, it is because na unbalanced force. Kay dili mo lihok si object if the object is in balance. So mo static na siya, but since it moves pasabot na unbalanced force nga nagbitad siya towards the right. So this is the case A. Let's proceed to case B. So say buhato na to ni case B. We have case B here. So drawingan gyapon nato og FBD. So our FBD here. So since the motion is towards the right, we can just pwede na tayo mag-drawing FBD, but we summarize force diretso along X is equal to MA. Since wala man po yung naka-incline nga force. So itong force along X is only this one, 2.5 S is equal to the mass, which is equal to 10, and the acceleration A. So our acceleration here is equal to 0.25 S. Now, saan man nato pag-solve na ay function of S? If you remember in our constant kinematic equation, so this is not a constant, therefore we cannot use the constant kinematic equations. We should use the non-constant one, katong the v times the derivative of v is just equal to the acceleration times the derivative of the position ds. So you have here v dv is equal to, ang a na to is 0.25s, 0.25s ds. Integrate both sides. So from this one, the lower limit is 3 because the initial velocity is 3 meters to v, which is still unknown, and then from distance 0 to 8. So here we have 1/2 v squared from 3 to v is just equal to, this is s already, so we have 0.25 over 2 s squared from 0 to 8. Substituting these limits, we have 1/2 times v squared minus 3 squared is equal to 0.25 over 2 s 8 squared minus 0 squared. Makancel ni si 2. We have v squared minus 9 is just equal to 0.25 times 64. V squared is equal to, so 0.25 times 64, 16 plus 9, that is 25. Subtracting the square root on both sides, we have velocity is equal to 5 meters per seconds. So for part B, our velocity is still 5 meters per seconds for force 2.5 s. So pila man ni ang force na 2.5 s at 8 meters, so that is 2.5 times 8. That is 20 newtons to the right. So 5 meters per seconds, 5 meters per seconds. Sir, kanang lahi lagi ang kuan ang sa module. So actually naay sayop si diri sa module no, naay mention forces along X. So along forces along X we have 2.5 s and then 10a. To get a, we divide the whole equation with 10. We divided with 10. So, dapat ato acceleration is equal to 0.25 s, not this one. To come up with this answer, dapat ang ato ang force is not 2.5 s, but F is equal to 25 s. Then we'll reach with this answer nga 13 meters per seconds. Okay?